Binary representation. Binary data structure is represented using two methods: array representation, linked list representation. Consider the following tree. This is the tree is there. Okay. Then array representation of the binary tree. One-dimensional array, 1D array to represent the binary tree. The above example of the BT is represented as follows: A, B, C, D, E, A, B, C, D, E, A, C, D, F, G, H, I, J. Then we have blank K. Okay, to represent the binary tree of the depth n using the array representation. We need the one-dimensional array with the maximum of 2n plus 1. Okay, now next is the tree. Okay, next linked list representation of the array binary tree. We use a double linked list to represent the binary tree. In the double linked list, every node consists of the three fields. First fields of the sorting left child address, and the second for the storing the actual data, third for the storing the right child address. In the linked list representation, node has the following structures. In the above example of the binary represented using the linked list as shown below: root node B, C, D, F, null, G. Okay, and this represent last node is explanation of the array representation of the binary tree. The array representation of the binary tree can be done using the technique is called level order traversal. In level order traversal, the elements of the binary tree are stored in the array in order in which they are visited in the burst first search. The array representation of the binary tree allows for the efficient access to the elements of the tree. For example, if the binary tree has n nodes, the array representation of the tree can be stored in an array of the size n, allowing for the constant time access to each node in the tree. In this representation, the root node of the binary tree is stored at the first position of the array, and its left and right child are stored at the second and third position respectively. The remaining nodes are stored in the same way, with the children of each node consecutively positioned in the way. For example, consider the following binary tree: 1, 2, 3, 4, 5. The level of representation of the trees in the array would be 1, 2, 3, 4. Using this representation, it is possible to access the children of the node at a position I by using the following formulas. Left child node I can be found at position 2i plus 1. Right child of the node I can be found at the position 2i plus 2. It is also possible to determine the parent of the node at position I using the formula. The parent of the node I can be found at position I minus 1 by 2. In this context, I have a binary heap or a similar array-based representation of binary tree. The left child of the node at the index I is located at the position 2i plus 1, assuming 0-based index 8. Binary heap representation. When a binary tree is represented using an array like an heap, the root node is typically at the index 0 or 1, depending on the indexing conventions. The left child of the node at the index I is always at 2i plus 1, and the right child is at 2i plus 2. If the parent node is at index 0, the left child left side is at index 1, 2 are 0 plus 1 equal to 1, and the right side is at the index 2 star 0 plus 2 equal to 2. If the parent node is at index 1, the left side of it is index 3, 2 star 1 plus 1 equal to 3, and its right child is at index 4, 2 star 1 plus 2 equal to 4. The array representation of the binary tree can be useful in algorithms that requires fast access to the elements of the tree, such as searching and sorting algorithm. However, it is important to note that not all libraries trees can be efficient represented in the array, as the number of elements in the array must be known as advanced. Additionally, some algorithms may require a different representation of the binary tree, such as linked list representation. Dry run of array representation of the binary tree with example. For an array representation of the binary tree, we will form an array of the size 2 star n plus 1 size, where n is the number of nodes in the binary tree. Now we will move to the step by step for the array representation of the binary tree. First, suppose we have a binary tree with 7 nodes. Now the array representation of the binary tree, we have to give numbering to the corresponding nodes. The standard form of the nodes is to start from the root node and move to the left and right at every level. After numbering the root tree, the nodes will look like this one: 0, 1, 2, 3, 4, 5, 6. Now we have numbered from the 0. You can simply place the corresponding number as the matching index of the array. Then the array will look like this: 7, 0, 1, 2, 3, 4. That is the array representation of the binary tree. But this is CC case, as Google Code has to So that about the